So two of the most commonly used terms when it comes to scaling databases is sharding and partitioning. Let's spend some time understanding what each of them are and how you use them to scale your database, right? So to be honest, people use sharding and partitioning interchangeably, but the standard definition to that is sharding is a way to distribute the data across multiple machines, and partitioning is when you are subsetting the data within the same instance. It's very it's very superficial, to be honest, but you'll understand when we go deeper into it, where we use shards, where we use partition. So typically partition is about data, shard is about database, right? When you have multiple databases, it's sharding. Otherwise, when you are splitting the data, it's partitioning, right? Okay. Now let's talk about how databases is scaled so that we understand where sharding comes in and where partitioning comes in. So a database is nothing but a simple MySQL process. Let's say I'm taking example of MySQL over here. A simple MySQL process running within an EC2 machine with an exposed port of 3306. Anyone who wants to talk to it talks to this port. The request is forwarded, like request is handled by your MySQL process. It gets things done and sends it back, right, over this network. This is just a single EC2 machine that we are talking about, within which the MySQL process is running, right? So this is what your database is. Now, every database has a limit, the number of requests that it can handle. Let's say we have a teeny tiny database to start with, and this database handles a request of 100 writes per second. It's good enough load, but your database is fast enough that it is able to handle that much of load. But now, let's say you got a little more users, right? Now you got little more users, so now what would you do? Little more users, now you'd want to handle, let's say, 200 writes per second. Now the first thing what you would do is you would scale up your database, right? You would scale up your database that, hey, your database was teeny tiny, let me scale up, right? Will not add complexities of having another database at this stage. We would keep things very simple. We would just give more CPU, more RAM, more disk to our existing database so that it can handle 200 writes per second. We are happy, right? Now what happened is our product went viral. When a product went viral, we are unable to handle the load because now we are getting requests of 1000 writes per second. We said, hey, don't worry, we are on AWS, Azure, GCP, whichever. 2 clicks, our database is up. We upgrade our database to very huge size. It's a maximum that they had to offer, and now we can handle 1000 writes per second. Very happy, right? Our product went viral, we are making revenue, whatnot, right? Okay, now what? Now you get even more traffic. When you get even more traffic, and you say, oh, AWS or your cloud provider does not have an option to go beyond it, now what would you do? Vertical scaling has a limit. That's where you scale horizontally. So now what would you do? You say, hey, I still have one database which is able to handle 1000 requests per second, 1000 writes per second. Now what is happening? I'm getting more than that. Now the problem here is that if I put all my data in one database and then that database itself needs to handle everything, it's a problem. So what if I distribute the data across 2 databases? Let's say I take 50% data, put it in one database, take rest 50% data, put it in other database. So now instead of one database, I am having 2 databases, each having 50% of the data. Now what would happen? That same instance that was handling 1000 requests per second will now get, because of 50% data, it will now get 750. Now let's say the number of requests that I'm getting is 1500. Now I have to handle 1500 writes per second. So I split the data into 2. So the database has limit of 1000 writes per second. But now because the request that I'm getting is 1500 writes per second, 50% data split implies that first database would get 750 writes per second. Second database could get 750 writes per second, but their capacity is 1000. You are very happy with it, right? So you are able to handle with horizontal scaling. You are now able to handle the number of requests which are more than what you could handle with vertical scaling. With vertical scaling, you could handle at a max 1000, but now because you split the data two-way, you are now able to handle 1500, and it can go beyond, it can go till 2000, because Each database has limit of 1000 writes per second. You have two database, so the total number of requests you can handle is 2000 writes per second. So 1500 writes per second is nothing because your limit is 2000, right? So you are able to handle the load. That's the beauty of horizontal scaling, and this is what you do to horizontally scale your database, right? Now this is what we call sharding and partitioning. Here what we did is we partitioned the data, split it 50%, put it on two different shards, right? So each database server where a partition of data or a partition data is served is called a shard, and the data is quote unquote partitioned. It's a very oversimplification, if I may put it, but you get the idea that a data is partitioned, multiple data servers, multiple database servers is a shard. So overall, you can think of it like that a database is sharded while the data is partitioned. So when you say I have multiple shards, implies I have multiple database servers, right? And when someone says I have my data partitioned, it means the data is split. Maybe stored in the same server, maybe stored in different servers. It's just more about data being partitioned. It doesn't say anything about where it is served, right? Okay, now let's go deeper into partitioning. Now let's say I have 100 GB of data, which I'm partitioning in 5 partitions. Right? Some strategy I applied and I want to partition it in 5 partitions. First partition is 30 GB, second partition is 10 GB, third partition is 30 GB, then 20 GB, then 10 GB. Now these are 5 mutually exclusive partitions of my 100 GB data. Now what I can do is I can choose to store these partitions across 2 shards, where I can say, hey, A and C partition will live on shard 1 while B, D and E will live on shard 2. It's my logic, right? I can keep the partition wherever I want, in whichever shard I want, so long as my API server knows that if I'm getting request for this key or this data which is part of this partition, which means it would be part of this shard, so long as my API server knows how to route the request to the corresponding shard, I'm all good, right? Which is what your logic with API server should be. In the previous video, we saw that example, right? And I hope you implemented the exercise that I said. That's exactly what we are trying to do over here. So here we partitioned the data and we are now splitting it or distributing it across multiple shards. Right? Now, how we distribute it, it's just like I just took a random example to distribute it. Here I tried to distribute it almost evenly with respect to load, but there is nothing specific. Now, for example, if one of the shard gets hot, I can just take that partition and move to other shard. That's load balancing that we're talking about, right? But this is the idea. This is the idea of sharding multiple databases and partitioning, splitting the data into mutually exclusive subsets. Okay. Now, how do you partition the data? Partitioning of data can be done in 2 ways: vertical partitioning, horizontal partitioning. Vertical partitioning, let's start with horizontal. Horizontal partitioning is the most common way to do it. Horizontal partitioning says that, hey, within one table or within one document, within one collection, within one table, I can pick some rows, put into one database, pick other rows, put into other database. So that is horizontal partitioning. You are not splitting between, or you are not splitting the data, like you are not splitting the row. You are rather taking a bunch of rows, moving to one database, taking other rows, moving to other database. This is horizontal partitioning. You are slicing it horizontally, right? Then example of vertical partitioning is where you say that, hey, I want to have these tables in one database and these other tables in other database. This is example of vertical partitioning. You are not slicing it horizontally, but vertically. You may choose that, hey, these 3 tables goes to first DB, this other 3 table goes to second DB. So you are partitioning it vertically. And depending on use case, you would pick one over other. Horizontal partitioning, to be honest, is very common. Vertical partitioning is an example of monolith to microservices. If they are buzzwords, take some time. You don't need to know about it right away. Just make a note of it. By the end of this course, you would have an idea on what I'm talking about, right? But just absorb those things at the moment, right? This is about partitioning. Vertical partitioning, horizontal partitioning. Now, let's look at all possible cases, right? What happens when you partition the data? When, let's say, what I did is I just took like normal like engineer stuff, right? So 0011 1011 wala thing I did. So let's say I have partitioning on this axis, no yes. I have sharding on this axis, no yes. So when I'm not partitioning and not sharding the data, it means that I just have one database server in which I'm having one data. It's like your standard monolith. Everything is there in one database. You're not doing anything with it. Every request goes to that. So you're neither partitioning nor sharding the data. It means it's your monolith. Everything goes to that one thing to get handled, right? Now, let's say you are not sharding, but you are partitioning the data, which means what you are doing is your data within that database, you are creating two databases. Like within that one database server, you are creating two databases to have each individual partition of data. For example, why you do that? Let me start with that. So let's say you have your MySQL server. You did a create database. Let's say you are running two microservices. First is authentication. Second is profile, right? So what you did a create database authentication, create database profile. This authentication database that you created is one partition, and the profile database you created within that same MySQL server is other partition. That is not sharding, but you are partitioning it. So both exclusive subsets of data are still lying within the same database server. That is no sharding, but partition data, right? Okay. Now let's talk about when you have sharded and partitioned the data, which means what you are doing is you are now having the authentication and profile that we talked about. Now imagine you took that authentication database and move it into a different database server, while profile database is on another database server. You have partitioned the data and put into two different databases. This is like classic microservice. You have authentication microservice, you have profile microservice. Now you'd say, but we just put it in the same database. Earlier you didn't have enough traffic, but you still wanted to be future proof. So that's why you created two different databases within the same database server, serving that same request, right? But now you have money. Right? Let's say you got funding, you have money, you can spin up another database, you keep authentication over here and profile over here, and now it would be able to handle good enough scale, each one of them independently. Now, so for scaling, when you have money, you do this part, right? So partitioning and sharding, both cases is this. Now, one very interesting case that is pending is what if you don't partition the data, but you shard it? So which means that you are not splitting the data either horizontally or vertically, but you are using multiple database servers. Where would you need it? Read replicas. So you have the same data present across two databases. This is like a classic read replica. This is how you scale reads, right? So no partitioning, but sharding is an example of read replica, right? So this is what partitioning and sharding is all about. Now let's end this with understanding the advantages and disadvantages of sharding. So advantages of sharding is you handle large reads and writes. We saw that, right? Vertical scaling had a limit. We could only handle 1000 writes per second, but because we sharded, we could now handle 2000 writes per second. But our limit was 1500. We were good enough to handle that much offload. Second, we increase the overall storage capacity, right? And we have very high availability because if one of them goes down, our system is at least partially functional. Right? But disadvantages is you see how operationally complex it got, having multiple shards, having that routing logic to where to go to. Now you cannot make cross shard queries because cross shard queries are very expensive. Imagine you writing a database transaction spanning these two totally different databases. That would slow things down. You would not have consistency. It becomes very messy. You need to go into distributed transactions and whatnot. People typically refrain unless there is a very high need of having cross shard queries. Then like people try to minimize doing cross shard queries. They have shards, but in most cases the way data is sharded, or rather the way data is partitioned, is such that they would never have to make cross shard queries. This is how typically senior engineers decide on what parameter should we shard the database or should we partition the data. We try to minimize cross shard queries. That's the heart and soul of any distributed database design. As soon as you want to do cross shard queries, you will definitely see a huge drop in performance. You would see distributed transaction messiness. Your code would become ugly. Your system would be prone to so many failures, which is why when you shard the database, you would always try to minimize the amount of queries you would have to make cross shard, right? This is the high level overview of sharding and partitioning. So yeah, I hope you found it interesting. Hope you found it amusing. That's it for this one. I'll see you in the next one. Thanks a ton.